Airfield Lighting Maintenance Best Practice Part 2. Today we have a very esteemed panel. We have Tony Smith, world-renowned inventor of the PAPI. Seward Ford has joined us, a specialist airfield lighting consultant with experience working many years at Kraus Heinz, and as a AAA airfield lighting trainer and now independent consultant. Keith Costel, of course, recognized worldwide as a specialist in airfield ground lighting, has just come back from training in New Zealand and Singapore, I believe. Experience working in the Royal Navy, many years service manager at ADB, and is director of TMS Training Solutions. And special guest today, Carl Johnson, senior aviation specialist at Avcon and world font of knowledge, and start every time I go to IES in the States, which is the largest airfield lighting conference, is always the star presenter. Well done, Carl. I'll keep trying. It's a huge topic. We're going to carry on now with some case studies, but just to remind you of what we were talking about last week, or last month, in fact. Best practice requirements. In order to determine best practice, which is unique to each airfield and each environment, you need to know your airport. And that means you need to understand it, because it will have unique differences. There's no silver bullet when it comes to best practice for airfield lighting maintenance, although the principles, which we will explain through some case studies today, will give you a very good idea. But the basic principle, a process we term differential maintenance. It's in the Aerodrome Design Manual Part 4, is to first measure, then maintain, monitor, and then use that data to manage your airfield lighting systems. Why? Why do we do this? Well, it's to enable airports to make faster and clearer decisions based on using data real time. Historically, methods can be somewhat subjective, but we need to make, we're in the 2020s now. We need to make decisions based on real data, not subjective decisions. So in order to do this, you need an effective airside computerized maintenance management system, or CMMS, an airside CMMS. This will enable your airports to centralize maintenance information, facilitates the processes of maintenance operations, and helps optimize the utilization and availability of airside assets, including the visual aids, the electrical infrastructure, and pavements. So all giving you gains in performance. Operational benefits of adopting this approach would be better resource optimization, systems integration, and operational improvements. And that will result in the number one benefit, the non-negotiable benefit is safety and compliance. That has to step in front of everything. I find it very frustrating when we're talking about matters of compliance, and the issue of lack of budget comes into play. It's not if you do it, it's how you do it. Safety and compliance is not negotiable. But with safety and compliance comes greater operational availability and reduced disruption through performance-based maintenance, predictable ways to optimize maintenance efficiency, aiding better and quicker decision making, improved traffic throughput through greater runway availability and more efficient operations, facilitating follow the green, for example, and reduced operational costs. Ultimately, you cannot manage what you do not measure, and that will come as a recurring theme as we go through today's presentation. So what are you going to do to measure airside, to measure your airside operations? You're going to use a CMMS that will allow the airport to digitally record and provide an audit trail of all your activities, covering everything in the maintenance cycle from scheduling of maintenance to recording the results. So for civils, for example, that will include everything to do with the runway surface condition, same for taxiways and aprons, everything, all inspections, faults and repairs being recorded. Mechanical, for example, on lights, you would measure torque, the final torque, the angle moved, so you can intelligently plan your maintenance cycles and monitor the work has been done and you're getting the desired results, but also to more effectively manage your torque management operations in the future. You record the inspections, the faults and the repairs, and of course any physical damage, because whether it's the tow tugs damaging the lights, or snow removal and grass mowers damaging the elevated fixtures on the edge. All of this needs to be recorded and used as part of the management process. Electrically, you need to measure insulation resistance, of course, record inspections, faults and repairs, and use those as part of your best practice maintenance process. And then photometrically, we have airside mobile to in-field mobile testing, testing of lights in the workshop to ensure that the fixtures that go back on the runway are fit for purpose, measuring the photometric performance of tappies, guidance signs, apron, floodlighting, and again, all the inspections should be recorded. Who did it, what they used, was the equipment calibrated, what the results are, and are there any what repairs have been made. Also, integrating with the control systems to feed information from those sources, and we're starting to see increasing telemetry for the other performance information coming from the intelligence that's being now built into the lights that is accessible by the control systems, and that's one of the new ways in which an airside CMMS will be evolving over the years to bring all of the relevant, all of the available information to support 21st century maintenance operations. Ultimately, this is all about optimizing utilization and availability of airside assets and, of course, achieving safety and compliance. So let's look to the case studies. First one we've got here, and thanks to my friends at London Stansted Airport for this one. This was a data-driven decision, of which all of the items we've got presented today are. They're all based on the results of data collection. The problem here was there were performance issues with the lights, the halogen lights at this airport. There was one particular incident, and also the amount of maintenance that was required to actually maintain them in a compliant state, or as you can see here, a non-compliant state, was causing a real headache to management. Interventions were virtually monthly in terms of replacing lights. In some lights were being replaced monthly. The cycle between maintenance interventions was growing smaller and smaller because of the conditions of the airfield lights. However, although LEDs were put forward as a solution, a competitive capital expenditure environment at the airport required the airfield lighting team to put forward a business case to support their gaining access to quite a large sum of money from the capital budget for the year. Otherwise, other areas would take the money. Management, as will be the case in many of your airports out there, refused to make any investment without a solid and live data-driven case. And so what they did, they were able to draw. This was a company that did regular, Stansted Airport has always done regular photometric testing, and they put together a business case, and they were able to demonstrate a saving resulting from reducing the amount of maintenance and also the benefits of achieving safety and compliance on a routine basis to support the investment in the LED technology. But like any major corporation now, an airport's no different. They were also required to do a post audit review of the project to demonstrate that actually achieved they could actually achieve the results that were put forward in the business case. And so, as you can see in their analysis here at a very high level, the lights, instead of hovering around a compliant level and having to be fixed regularly, they jumped up in performance to over 125%, and they're able to maintain that period and have continued to do so for a sustained period. The only maintenance interventions now being required are cleaning of the lenses, which is something you have to do even with LED lights. If you're looking here, this bottom chart shows the number of faults reported, and you can see they were running around about 600, well, they got up to, I think, the peak of 800 a month. And when the LEDs were installed, they reduced to in the order of less than 200, and that was basically cleaning the lights. So the amount of maintenance that was required to achieve compliance was considerably reduced, and rarely involved actually changing any lights. So it was a successful project. Looking now at signs. In this case, the CAA highlighted the requirement, had identified poor signage, non-compliant signage as an issue at this airport, again Stansted, and Marcus Jelliman, you can see posing in the center there for us. Again, CapEx is constrained, but this project was justified on corporate and social responsibility. This was a mandatory requirement, absolutely essential to replace. And in this particular case, the airport decided to do a trial of replacing the incandescent light sources, fluorescent tubes in this case, with LED signs using the LED panels. So they changed the light source in existing signs. You can see an example here on the right-hand side of the sign before the LEDs were replaced the fluorescent tubes, and then here after they replaced the fluorescent tubes. And again, they asked us to come in and perform measurement, and we were able to demonstrate the success of these retrofits to achieve compliance. I'm going to keep running through these because there's an awful lot to get through, but these are kind of examples. But you'll see that the message from these first two, we're looking at data-driven decision making, and then monitoring performance to ensure that the desired results are being achieved. If you do have any questions, there's a Q&A box on the on your Zoom screen. Please enter those in. We are also going to be taking, just in case anyone was forgotten, there were some questions left over from the first presentation, which we will also try and take in the time available. So, looking now at looking. Oh, this is so. This I will jump this one. We've already talked about the sign. Looking at the PAPI now. What's a good PAPI light unit? Well, a good PAPI has a good. The vertical angle is where it should be. In this example, it's 2 degrees 30 minutes. It's 232. It has to be within 3 minutes of the reference value. The intensity of the red and the white need to achieve the reference value. The red has to be red, the white has to be white, and the transition has to be sharp. So the range of the transition. And you can see here the measurement. This is a sharp PAPI. You can see the beams are nicely aligned. And if you actually measure them precisely, you'll see the beams are 2 degrees 33 minutes, 32 minutes, and 31 minutes. So they're very closely aligned. A good PAPI. This is an example of a bad PAPI unit. The intensity is down. The red is below the threshold of 15,000 candela. The setting angle, well, because you can see the beams are not aligned. The central beam is 2 degrees and 10 minutes. The other two are indeterminate because they're so far off. So that will result in a very pink transition for any pilot. This is an example where the PAPI has been set using a clinometer, but the actual PAPI projectors themselves are not are not projecting a beam at that vertical angle. Very important. When using a clinometer, don't use the box. Use the specific platform provided on the PAPI unit for setting your clinometer. But also, one thing I see is that you need to measure the horizontal as well as the vertical angle. Very often we see PAPIs that are sloping because the horizontal angle is not being checked. So that's another important thing to check. But here we have the results you can see of a very poor PAPI. Measurement again is key. So what are the issues with what affects the PAPI results? Well, the age and condition of the bulbs, the reflectors, the lenses, and the filters indeed. The internal and external cleanliness. You'll see build-ups both of dirt inside and outside of the actual PAPI itself. Misaligned filters. This particular example on the right-hand side here, you can see this PAPI is sloping. So the left-hand projector is completely red. The middle is roughly aligned, and the bottom is you're getting a large white sector. Vegetation. All too often, you'll see grass or plants growing in front of the PAPIs, partially obscuring the PAPI unit. And then physical damage to those PAPIs caused by a variety of implements. It could be snow being thrown out from snow removal equipment, or grass mowers coming too close to the PAPIs. Moving on, when you look at any of your visual aids at the airport, can you answer the following questions? What elements does the daily check include? People go out and do daily checks, but what do they actually check for? We can say, well, look and see if any lamps are out, but are they required to check the levels of vegetation potentially obscuring the lights, to perform a bob check to see if they are broadly aligned? It's a crude check, but it's still a very effective way to crouch in front of 10 meters in front of a PAPI to see if all of the beams are changing simultaneously. What are the historic measurement trends for your PAPIs? Do you know the vertical angles, the transition, intensity, and color measurements? When was the horizontal level last checked? When did you last do a check for the PAPI? When was the PAPI last cleaned? When were the bulbs replaced? Do you have a policy of replace on failure, or based on photometric measurements? And if you do change them, do you change them all or as they fail? When were the filters last replaced? And when was the vegetation last cut? All of these factors are very important to the performance of the PAPI, but do you measure them? Do you have any record on which you can base your management of those assets to improve it and to ensure the results are achieved, but also achieved in the most efficient manner? Looking now at apron and stand testing, I'll just present one slide here. Typically, we perform these tests most often on newsstands, but most airports require an annual check as well. They highlight all kinds of issues, but looking at a hotspot report to see which points, which measurements are compliant and which are not, you can see very readily that the top right hand, the furthest right hand measurement, very low light levels. However, the average performance of this PAPI is compliant. Of this stand lighting is compliant, but we see many that are not. all kinds of reasons. Most recently, there was an apron that was built behind, away from there was a perimeter road built between the masts for the floodlights, and which wasn't in the original plan specification for that lighting. Consequently, there wasn't enough light cast out to those farthest most points on the stand, and it actually failed. We tested it for the with the lights had been in the correct position, and we were able to determine it was the problem was in fact the road, where the road was situated. There's another case where the stand was situated between two masts, and there wasn't sufficient light in between those masts. They were too far apart to give the correct lighting for that stand. Again, you know, it's not a subjective measurement. It looked dim, but you need a measurement to be able to determine, is it compliant or is it not compliant? And if it's not, why is it not compliant? Airfield lighting cleaning. Airfield light contamination on airfield lights is by far the most significant factor for poor photometric performance. But the question is, how do you do it and how often do you need to do it? Again, it all comes down to measurements. You need to make database decisions. The objective was to get improved photometric results. You want to do cleaning that's quick and easy and with the minimum disruption to air traffic. We've done numerous studies. Again, each airport will be different. But the first point to note is the difference between manual cleaning results and in this case, soda-based MARMS cleaning results. We went to an airport where to test to demonstrate the MARMS cleaning system, the manual cleaning machine, which uses bicarbonate of air and soda to clean the lenses. And when we got there, we found that the lights had been cleaned manually the night before. Now, for a demonstration of the effectiveness of a cleaning machine, I thought that was pretty disappointing, because the lights were already clean, or were they? We were there, that everybody was assembled for the test, so we did it anyway. And what we did was we did a photometric test of the lights, then we cleaned the lights with the MARMS cleaning machine, as can be seen in this picture, and then we did a further MARMS test, photometric test of those lights. The results we achieved at this particular airport were a 23% improvement in the light output through cleaning them again with a soda and air-based system. This is reflected in the experience shown at Stansted Airport here, where the same manual clean was performed and tested, followed by a soda and air MARMS manual cleaner test system. The significance of this, we say, well, they're both compliant, but of course, by achieving a far higher level of compliance, that means the next maintenance intervention will be required far further away. So if you can clean the lines effectively, those lights will stay compliant for a much longer time before you have to go back and clean them again, which is of course a significant cost saving, but probably for the airport, the biggest benefit is having reduced disruption to air traffic, because many of these airports, and Stansted as an example, is a single runway airport, and it is very disruptive to have interventions which require equipment on the runway. Often, the runways have to be closed for a period to air traffic. The contamination will build up at different rates at every runway light location, and a single movement can destroy the performance, the photometric compliance of a light in just one landing. we did a test at another UK airport here to actually measure how long it would take for lights to become non-compliant. So the lights were cleaned, deep cleaned, such that they were 100% compliant on day 0, as demonstrated by photometric measurement. And then we measured subsequently at further days after so many days. Now this significantly in a UK environment, the winter time there's far more contamination, there's far more dirt and there are far more fluids, de-icing fluid, for example, present on the runway, and the contamination of the runway lights happens faster. So the cleaning regime will be different in most airports in a northern hemisphere situation in summer, in winter to summer, but that will be different for different climates, because the potential for rubber to melt will obviously be affecting hotter climates adversely in hotter periods. But in this particular example, we calculated that that an airport needed to be the lights need to be cleaned after 8 days routinely to achieve compliance, and immediately following a de-icing event. So every time an airport is de-iced, you had to clean the lights, because the de-icing fluid they were using contaminated the lenses to such a bad extent. So what I would recommend is that whatever your cleaning method, you need to perform photometric testing to determine how often you need to clean it. Cleaning is not something you do twice a year, or in some airports I have come across, never. They're only cleaned when they're replaced because of failure. And remember that most airports that will be on this call today will use instrument runway visual range equipment, and the calculation of your instrument runway visual range will be based on a formula that uses the assumed intensity for your runway lighting as part of the calculation. And if your lighting is not at that level, your declared runway visual range, the figures that are given to the pilots on every takeoff and landing, will be overstated, which is clearly dangerous. So now let's look quickly at civils. I'm just checking how we're doing for time. Good. When you're measuring your civils, it's important again to record what's actually going on out there. In this particular case, again, we're looking at Stansted. They were previously recording and tracking faults via Maximo, and they found the system, let's say, difficult to use. The surveys took too long, required significant knowledge and training, and multiple tablets, equipment, etc. So they looked at an alternative way, and they actually asked us to help in this instance. And so what we've started to do was to measure the airfield, measure the faults using a CMMS, and recorded the issues by category, by nature of fault, and recorded the repairs on a regular basis, so that we had the data that you'll see how it's used in a future slide. So each defect is recorded, each temporary repair is recorded. A pin is put in there, a photograph is taken of the particular type of fault, and that data is then able to be used to develop a longer term maintenance action that can be performed during a scheduled closure. Using a CMMS to actually record the different types of faults and where they are, they can be sorted into layers to categorize them, developing along by type and the severity of the fault, develop the management process of determining which actions are recorded, which are required for where, and then using all of that data, use the information to actually schedule a long-term fix through a deeper repair at the time scheduled as part of the annual closure cycle, rather than have to do extensive, fix all of the pavement regardless. We promised also to cover with you today a little description of a sapphire versus traditional glass repair of lights for lenses, regular lenses. Now, this is using some data provided by our friends at Halifax, and I'd like to thank Matt Flynn for this presentation, which he made a couple of years. This is the part of the presentation he made at in Canada, Swift, I believe it was. They had a problem there because their lighting performance was particularly poor, in particular following winter periods. Again, they use the term data drives decisions. And thank you for that heading here. This I've just taken the words from Halifax, which is so you can see here that the lighting performance was clearly non-compliant. So what did they do about this? They looked at the problem and discovered that particularly in winter periods, the lenses were deteriorating. On the left, you'll see a sapphire lens, but on the right, you'll see the lens from a light in operation in the winter in Canada. And there they use some mighty snow removal equipment, wire brushes, that scratches the lenses and destroys their photometric capabilities. And so the question was what to do about it. They did a trial using sapphire coated lenses, the ones on the left, and the result was immediate improvement. In fact, I've seen if I just go back a slide here, I've seen lights. You see the regular lens picture there. The actual aluminium coating casing around that lens. I've seen lenses with all of the aluminium scraped away, and the sapphire coated lens just sitting proud of the aluminium, without a scratch on it. Such is the hardness of a sapphire lens. Really incredible. And we had recently at a seminar, I know Heathrow has employed sapphire coated lenses to great effect, and on both runways there. It makes an enormous difference, because if lenses get pitted from sand or from jet blast or from damage from snow removal equipment, that will destroy the photometric performance, and the pilots will not get the visual cues they need. But in the case of Halifax, you can see here, this was the result afterwards. The chart of before was completely red, and that's the result primarily of great maintenance, but helped in large part by sapphire coated lenses being deployed. So there are other benefits of data to help support data-driven decisions, of collecting information, and of knowing your runway. Again, we're trying to get away from previous methods, which was historically somewhat subjective. You're able to measure supply performance of whatever components they may be, and work with your suppliers to address any issues based on the data. Mean time between failure of any aspect, be it a lamp, a light fitting as a whole, any part of the visual aids infrastructure is a very important assistance when you're actually talking with your suppliers to address these problems. Identifying epidemic faults with electronics electronic components can be subject to what is termed epidemic faults when a particular component reaches the end of its life, and you will see multiple failures. These data-driven systems collecting the measurements of the inspections and the maintenance work that you do will allow you to identify those epidemic faults far faster, not subjectively, and actually present them in a coherent way, again, to work with nobody does these things deliberately, but when they do happen, they're a big issue and they need to be rectified fast. Warranty management is another issue, with in particular some very extended warranty periods are very helpful to airports, but actually managing those visual aids primarily to see if they're still in warranty or not is particularly difficult without having the records to demonstrate when the asset in question was installed, commissioned, its performance through life, what has been done to it, and when the event requires a warranty intervention. And so ultimately, and it supports airports with achieving accountability with their partners. So a lot of benefits here from this. We can't never forget competence as part of this. You need to have the knowledge, the skills, and the attitude when actually performing these tasks. It's teamwork. It's having the correct assets. It's having great processes, but operated by competent individuals with the right skills to do the job, and training, and proper training, of course. Also, the measurement-based strategy works off the basis of we call differential maintenance. So you do your maintenance, you monitor the results of that maintenance. You then manage the you measure the assets in question, you do your maintenance, you monitor the results of that maintenance, and then you use that data built up over time. You have the history to actually manage the performance of your assets as part of a maintenance measurement-based strategy. And using tools such as hotspot, the presenting your data in a simply usable way, see the fault, the hotspot reports, heat maps to demonstrate where there are more frequent faults or issues. Same goes for torque, where you have the looser lights clearly can be identified by the brighter red colorings on this heat map, and layering to demonstrate the different faults of different types, so you can plan your maintenance actions for each type of asset. So all the tools are available here, all the data is available. So coming back to the initial slide, we need to know our airport. We need to base our data-driven decisions on a differential maintenance process, which collects all of the data, providing the audit trail from the beginning to the end of the process. This will enable your airport to make faster and better decisions with data that is collected real time, and an effective CMMS is integral to computerized maintenance management system, is integral to achieving the measurements that are required, integrated with the tools that you have to perform your maintenance, and to help you utilize the data with reports and analyses to point out the opportunities for improvement, increasingly using AI to be able to predictively anticipate the faults that you could anticipate, and the work, the performance-based work that you would perform. So, for example, we're now looking at in control systems where we're able to gather data from from CCRs to know how much, what intensity lights have been on, how long they've been on. We can now predict when a lamp is needed to be changed based on the historic performance, and having having the data to demonstrate how long that light has been utilized at each intensity level. And that's based on, of course, the environment where we're actually working, because different lights perform differently in different situations. So you will have your own unique maintenance picture profile to plan your performance-based maintenance based on the analytics gained from your particular airport. And again, the benefits: resource optimization, systems integration, operational improvements, and all giving you safety and compliance, which of course is paramount, greater operational availability, reduced disruptions by having any unplanned maintenance, predictable ways to manage and optimize your maintenance efficiency, giving you the opportunity to improve your decision making, improve your traffic throughput through less maintenance disruption to your runways, taxiways, and aprons and stands, and of course reduced operational costs. So that, in a nutshell, it gives you some examples of how we've actually worked and helped airports. They do the work, but we support them, and these are the lessons we have learned in terms of lighting best practice. The principles are the same and can be applied to all of your airside assets, basically. So I hope that's helped you. We'll take some questions now, but just before I do, just want to mention that the next TMS Tuesday on the 27th of June will be on the topic of after sales service. So I think that's another very interesting topic, and we look forward to presenting that one. Keith will be presenting that one on Tuesday, the 27th of June. So we look forward to that. And now we will take your questions, please.
Hello, everyone. It's Keith here, actually, online. There's a question that has come up, and that's something which frequently I am asked. It's about tolerances. We talk about the measurement and the angles, etc., associated with inset lights, the in-pavement lights, with the elevated lights, and it's pretty clear in the ISO candela diagram, and again with ICAO, and with the notes at the back of the ISO candelas about the tolerances associated with the runway lights, particularly the runway related lights. But when it comes to the PAPI, and it's interesting, Tony, you may have an input on this, please. The tolerances for the PAPI, because when we're measuring the PAPI and we're looking at the transition zone, and we know that when we set up a PAPI out in the field, then we give a tolerance associated with the 3 minutes of arc for the transition zone. We give a tolerance of a half a minute either way. So principally, then when we PAPI number 2 or PAPI B, which is the third out from the runway, then that's the first time that a pilot knows visually they are below the glide slope. And therefore, if we're measuring, what tolerance should we be including in there? Because when I go around the world, I see different tolerance levels being put in for the maintenance guys. And the second question is, if a maintenance guy finds that a PAPI is out of tolerance, what action does the maintenance guy take? Do they change it, or do they report it to someone on a different pay scale to make that decision?
Shall I, shall I answer the second one first?
Okay.
The setting angle, let's take anyone, 2 degrees 30, the outermost unit. That is the setting angle that should be obtained. And we know in practice there will be variations over time. I do have some concern that various places, there's various tolerances of 3 minutes. Our requirement originally was that at the end of the day, when you've done everything, the transition should be within 3 minutes of arc of the specified position. But if it is 3 minutes of arc, then, and this is what we did in our experiments always, if it was out by 3 minutes of arc, we didn't say, oh, that's all right, we'll come back another day and see. We readjusted it to read 2 minutes 30. So these are tolerances, in a sense, they're setting the boundaries of how frequently you need to do adjustment. And I have seen what you say, that I've seen a table, and I have an idea it was something in the US where there were 2 columns, one expressing 3 minutes of arc, which virtually said, well, this is what you should achieve when it's a brand new installation. But when you go and test it out in the field, you can have 6 minutes of arc and still be compliant. That's an absolute nonsense and ruins the PAPI signal. 3 minutes of arc is the absolute, it should never be more than 3 minutes of arc out. That's the desire. That's the requirement from everything.
That is something, you know, it is a subject that frequently comes up, you know, when I'm going to airports around the world, and I have seen plus or minus 3 minutes being you know, bandied about and written in their national standards. So this is where, you know, this is where we have to take a real close attention. And I know, Tony, you're working on at the moment a white paper on this whole subject of PAPIs, and it's something which, you know, I think we need to address to make it very clear what those limits are. And if we exceed the limits, what decision do you take on the ground? Because many of the requirements for a PAPI to be deemed to be serviceable is to have a flight check. And therefore, when do you have a flight check? Is it after its first installation or frequently?
I think, you know, I have real problems with flight checks because
Exactly.
it isn't difficult to do a few sums and just show that the accuracy of them, put it this way, you're trying to, with a flight check, you're trying to measure something where you need an accuracy of 1 centimetre with a ruler that is only calibrated in 10 centimetre. You know what I mean? See what I'm saying? You know,
I certainly do, and this is something. It's a subject which is coming up frequently.
Has got to be appropriate, and flight checking. I've done this many times just by pilots, you know, with a stopwatch or something, flying through, and so you can look at a flight check will check something like, well, do the lights actually change progressively from outside to inside as you join? A functionality you can check. You can check whether if you select on the approach lighting, if you select the different brilliancies, do you get different intensities? You can see that visually, but that's not the same as a precision check. And I would maintain that what we've got now is what we've needed for a long time. It's on the market, and TMS have got a means of actually measuring, as Robert's explained earlier, to small minutes of arc, knowing what we've got. And we should be aiming to be correct on the exact specification in our maintenance. But this is part of your learning. How often do I have to go and check to keep within the 3 minutes of arc?
It is. How would you address, from Stuart and Carl in the US, and in your the training courses that you give, and etc. How is this tolerance element addressed?
Basically, we would address the tolerance based on the manufacturer's recommendations or with what the FAA prescribed. And for a PAPI, we would always require it to be flight checked after whatever corrections were made.
See, this is the key issue, eh? This is where we're coming to. Then with the modern tools that are available, then it's more, I would suggest, the image analysis system, you can call it what you wish, on the modern photometric measurement tooling, the ground-based system is more accurate than a flight test.
It is.
Yeah, we've had a number of instances where we've failed the PAPI, but it's passed the flight check, and that just lends itself to that. You're looking at a flight check cannot tell the individual beams. It's looking collectively as a PAPI
Well, can I just say, Robert, your company exists because in 1973 I actually went to one or two of our airports and actually did some photometric measurements of the center line lighting, and found that they were all very deficient compared with the specification. One I remember in particular, I visited less than a week after they had had their flight check and their license restored, renewed by the CAA, and the light output from the 5,000 candela center line was less than 200. Flight checks aren't very reliable.
No. So
and it's interesting to get the views from across the pond, as we call it, Here in the UK, I always say when looking over at in the US and North America, we say across the pond, So it's interesting to have you guys from across the pond, to get your views on this, from a respected, authority from the FAA.
And I guess, Carl, you can confirm this. We over here, as Carl has indicated, the FAA does, they had their own maintenance people that maintain the PAPI. And very few airports own their own PAPI and service them. Some airports do, but it's a minimal number. And
a lot of our
so
GAs do maintain their own.
GAs, yeah, the small general aviation airports, yeah, maintain their own. But the sophistication going into that maintaining or checking of the signal is minimal. It's very minimal. And so what the FAA is doing on the Part 139 airports, we're sort of in the dark on that as to what they do. And there's a whole area there that needs to be explored, to say the least.
Well, it is because, the most dangerous or most critical point of flight is either landing and taking off, and of the two, landing is the most critical. And when we're looking at the landing, the principal system that we use for the visual aids is the PAPI. So the PAPI itself, becomes a highly important tool for pilots based on safety. And so if we're not defining the tolerances or even justifying the tolerances correctly, then clearly we are potentially affecting safety.
When you're measuring so when we're measuring the tolerance, it's clearly there's the 3 minutes of arc is critical for the PAPI alignment. But then within the measurement, and this comes back to the flight check, within the measurement, we measure each individual projector, whether it's 1, 2, 3, or 4. And if there's more than one and they're not aligned, then clearly they don't. You've got, first of all, the average of them all, which gives you a vertical angle. But if they are not all within a certain tolerance, and we define those tolerances within the measurement system to actually give a category, a focus, what we term a focus, as good, bad, or there's a good level, there is a warning level, and then there is a fail level, because you could have one PAPI set at the sharp transition at 240 and one at 220, and then the average happens to be 230. But clearly that's not an acceptable PAPI, because what you'll actually get, though the middle of the transition is the required 330, you will actually see a very, very pink transition in that case. So you need to have the measurements, and that's comes back to this, the key point of this presentation. Best practice is to measure your maintenance activities, and then record that information in terms of an audit trail of who did what, when, and where, and what the results were, and any actions to fix any problems, and then use that data to actually manage your assets manage and maintain your assets going forward. So
what I've done here, and just as an example, when I've been asked this question within a training course, what I do is actually we look at the actual installation that has been installed for that particular airport and the aircraft that the PAPI location, etc., has been calculated for, with or without an ILS. So, they're the two criteria. But then I demonstrate by saying, okay, now let's do a back check and do a back calculation utilizing PAPI B, and to demonstrate for the various aircraft types how the wheel clearance at the threshold is affected. Because clearly we need to achieve a desired height for the most demanding aircraft, for example, 9 meters, but we have a minimum height of 6 meters, for example, as one example. So I always demonstrate how to do a back check to see what the wheel clearance is for the various aircraft that utilize. Yep. And it's only then I start to see the dull, non-believing people start to say, oh, now I understand. Because it's about wheel clearance at the threshold when we do those initial calculations and those initial settings, as well as what the pilot sees and how they know when they are either above or below the glide slope and or integrated with the ILS, because the ILS is only within the inner barriers. We talk about PAPI B and PAPI C, that's the ILS band that the electronic system works to. Yet we have a wider band for VFR, and it's an interesting subject, Tony, isn't it?
It's an interesting one, because we had during the whole development, we had 2 examples of where PAPIs were reported by the pilots of being misaligned. In both cases, we found that actually PAPI found that the ILS installation was misaligned, not the PAPI. Because in one case, well, it was a military one where they actually had a precision approach radar talk down system. They didn't have ILS, and the pilots were complaining they couldn't always coming out high when they got to 200 feet. It was always high on the PAPI. Something wrong. We went through several iterations and then did a deeper study and found that the declared origin of this talk down procedure was in error as what was republished by 400 feet along the runway. And they never knew, using their flight calibrations and all the rest of it, had never known that they were 400 feet out. And the other one was actually at Heathrow during the summer months. We had the PAPI there for 3 years. During one of the summer months, pilots started to report there was a misalignment. When we investigated it, having done 2 or 3 weeks of checks and said, no, the PAPI's probably lying, we then found that they had downgraded their ILS, which was normally category 3, to category 1 for maintenance purposes, and the actual ILS signal they were transmitting was not 3 degrees. It was down near the edge of the 13 minutes of arc that you're allowed and before you trigger. So we actually showed them that the PAPI wasn't actually, the ILS wasn't actually giving 3 degrees.
Good. Well, thank you for sharing those experiences. I just coming on to the next question from Matt Flynn. Is there a way to clean? Is there a faster way to clean de-icing fluid? Because we need clean lights. We need to clean all the lights frequently in the winter and find the soda blaster to be overkill. Any recommendation? Can I just say that one of the issues is that there are 2 questions. One is, what are there better sorts of soda blaster to use? Are there better sorts of de-icing fluid to use that will cause less of a problem on the lights? I've never done a study of different sorts of de-icing fluid, but they are, some of them can be, they're particularly sticky and toxic, and they do significantly. We've done some testing here with one type, and they absolutely destroy the photometric performance. So it needs to be removed. And the other thing is with LED lights, which you have, that de-icing fluid is now sitting in the well in front of the lens, and is water destroys photometric performance. I can only imagine what de-icing fluid sitting there. It's not as fluid as water, and how long it must sit there before it gets removed by either cleaning or jet blast. Can
I interact there?
Yes, of course.
Robert? It was interesting because this subject has come up most frequently. I've witnessed now a material very, very similar to the soda that is used to take the rubber off pavement, and basically it's like a spray that the vehicle goes down the runway and sprays the material, and it's a fluid, sprays it onto the pavement surface. It's biodegradable, and it cleans and it's just left, and it cleans the rubber off the pavement surface. It has been shown that it is quite effective also for an element of cleaning of the lights. So it doesn't replace the cleaning of the lights, but it assists in the element of cleaning the light. So basically, it's a great big, like you see the vehicle that goes along and puts the anti-icing fluid on. Well, for example, well, it's the same kind of thing, but places cleaning fluid onto the pavement surface, and that in itself is an aid, has to be an aid. You know,
Does the residue though not go down the grooves and sit and get into
well, it
the?
depends. Not everybody has grooves. You know, they have you have anti-skid surface. You know, an anti-skid surface can be like 3 millimeters or so in thickness. So all I'm saying is that there are some methods and some things available, but it's not based upon our lights. It's based upon pavement. But you know,
there is also some coatings that we have developed, which I'm looking to relaunch, and that's Marm's Protector, which is a fluid to coat the lights, which just to prevent contaminants sticking to it. But I think I see the main issue as being whether it's water or, in this case, de-icing fluid sitting in front of the lens, and the only way to get rid of that is to blow. I would suggest is to blow it out, and so the cleaning system, the soda blaster would be. It may be overkill, but it's effective. So let's have I'll have an offline discussion with you, Matt, and we'll see what we can do and how we can approach this, because this is an important question. And I think if we could find the answer to this, it would be very beneficial for the entire group. We'll come back to that. I'll be in touch, Matt. Keith, talking about sapphire coating processes. Keith at IAVNO is saying that they've just done some sapphire coating on lenses, some sapphire coating of brand new prisms with sapphire. So I haven't seen the results of that, Keith, but that's an interesting to know that those sort of services are available, isn't it, Keith? That's Keith Spicer.
It certainly is, because we've saw that excellent presentation from London Heathrow and the work that they had done to investigate and to establish why, when they converted from tungsten halogen to LED, the performance results were not up to their expectations, or what they thought they were going to, the improvements they thought they were going to get, which initiated all this, the investigation that was undertaken at Heathrow. Out of that, it was clear that not just cleaning was an aspect; it was the deterioration of the lenses created by jet blast, and so therefore it's been a good exercise for us to be able to look at that. But I certainly know that the manufacturers and the suppliers of AGL lights, then they will offer a with or without sapphire coating. What the difference is in terms of how much money is there, I don't know. I don't get it. I haven't been involved with that, but I know there's a with and a without scenario, and I'm increasingly getting asked this question on training courses.
Right. Yes. So that's so watch this space.
Yes.
I've got a question here. After runway surface relaying, the runway centerline surface level at PAPI is increased 15 to 19 centimeters higher from previous levels, and there somewhere is read that 30 centimeter height variation is allowed. Please inform me, do we require to elevate the PAPI by increasing the leg height by 15 to 19 centimeters? Probably this is something that would need to be, I don't know. I would suggest that whoever that is, it's an anonymous question. If you email us with the specifics, we can certainly look at the geometry of your situation. But and see what needs to be done. But clearly, if you resurface, then that will affect things.
Well, actually, I think the question is a little bit here is a little bit confusing because you know the height of the PAPI at its location that has been calculated according to the most demanding aircraft that lands, regularly lands on that runway, then the aspect of location and ultimate the height of the PAPI and hence the center of the beam, which we've been discussing, then clearly it's not associated directly with the pavement surface. It's associated with the datum height of the runway at the center line of the runway at the threshold. Because we are talking, whenever we do our calculations, we're talking about the datum height. Now, if he's saying that the datum height has changed, then clearly location will be changed. But there are tolerances in that, and Tony, you know, when we're looking at those tolerances, there are some tolerances there.
Yeah.
And,
Right. We'll look at that. We can look at that one specific to the, but that's an interesting one and something that resurfacing will affect a lot of, does have consequences outside, a lot of consequences. Perhaps. Well,
it's not just that when it's resurfaced. Look at land subsidence, for example, yes. on runways that have been reclaimed, on land which are reclaimed from the sea. As an example, over time, land subsides.
Yeah. So we could do a webinar on just purely on resurfacing, possibly one. I think that'd be a good. Not sure if we could. We'll have a chat about that. Question for you, Carl. When a new installation is tested for its insulation resistance above ground, what's the impact of the mega on the cables? How would a cable with an earth fault behave in this situation? And how does this impact the personnel working in the field?
The newer insulation resistance testers are current limited, such to the point where they will not damage your cables. If you were to use a high pot machine or something and test it where the current is not limited, then if there was a fault, you would end up damaging your cables. So if you get the modern insulation resistance equipment, trade name a Megger, then it's going to be current limited and will not damage your cables.
Okay, good. Thank you.
There's a question for Carl, which came up and has come up to me recently. Then when we're looking at insulation resistance values and the guidance of allowable earth leakage, which is defined, associated with 2 microamps per transformer and 1 microamp per 100 meters of primary cable, and when we do the mathematical calculations, then using Ohm's law, then we get figures somewhere in the region, depending on the length and the number of lights, etc. We would get figures in the region of something, 20, 30 to 50 megohms. But when it comes to a new installation, then we would be expecting insulation resistance values at a dramatically higher value than that when everything is new. And then that becomes a discussion on, is it 1 gigohm or 2 gigohms for a new installation on a new project? What are your thoughts on that, Carl? Because I know you've done a lot of work on this area.
It's been several decades, but I tend to follow along with David Rainey's point. When we worked with him in Memphis, the new cable installation should have a minimum value of somewhere between 400 and 500 megohms. That would be the minimum I would accept. And if it's installed properly, connectors put in, sealed, the ends of the cable are kept sealed when it's being pulled. Because you cut the end off the cable and you drag it through wet conduit, that cable is just going to wick up the water. So if you keep the ends sealed while you're installing it, so that you don't get water in your cables, and it's a quality installation, the cable is pulled off the reels and carefully fed into the light bases. It's not dragged along the pavement. For a quality installation, you should be able to get 400 to 500 mega ohms easily on a new installation.
Okay, thank you.
All the FAA requires, Carl, as I recall, is 50 mega ohms minimum.
That's correct.
Which is dramatic.
they're way out of-
isn't it? Hmm?
Yes.
That is
I mean,
shocking.
Because providing then the insulation resistance values stay relatively in that region to the end of warranty for the installation contractor, then the emphasis then is placed on the maintenance contractors, and with and with the increasing density and the lack of availability to get out there to do any maintenance, it can be potentially a major problem.
Mhm.
So the knock-on effect of a lower quality installation is felt in maintenance, and if we have unserviceability based on IR, that will affect aircraft operations
Correct.
dramatically.
Thank you. Given, I've got a question here, which I'll ask Tony, but all feel free to chip in, because I'm very conscious that I was trying to think of, we have a lot of years of experience in this, between us, but none more so than Tony. And given the topic here of best practice maintenance, how have you seen? What are the major? How have you seen maintenance evolve over during the years? This is from Safe Riman.
How do you what?
How have you seen maintenance evolve? What are the major changes in maintenance practices and processes over the years?
I think the major change is that if we go back to the 1970s, which is probably far enough to go back, I think maintenance staff were given very little guidance or even any goals for their maintenance of AGL other than keep the lights on. And a carryover from other areas where lighting is provided, street lighting, what have you, it would be a good idea to do block changes so that you don't have, you do that as a periodicity so that you don't actually have lamp failures. But there was very little, well, there was nothing really, certainly from ICAO to say you must maintain the, after all, in a sense it did say your central line light, the minimum shall be. The shall means it's mandatory. It's a bit naive to think that, well, so you would get 5,000, wouldn't you? One of the things I found out in early work I did that led to the requirement for in-service maintenance, when I was doing the testing back in 73, what I found was that if you went to the maintenance staff, their ambition and goal was basically a nighttime drive around and change any bulbs that had failed. When I pointed out on the taxiway lighting that they were only getting a small fraction of the nominal requirement, they told me, for example, they had omnidirectional green central lines. I said, what's the intensity? They said, 30 candelas, because that's what it said in the book. I measured them and got 3. And some of that, of course, was down to little or no maintenance. But the other thing that happened was that it was at the level of the foreman of the maintenance crew that were doing the night work. It wasn't done at any high level of management. They were adjusting the primary current in the B center to enable them to maintain the number of lights they'd got. In other words, the manpower they'd got was sufficient for them to be able to change all the lights that had failed that night. And so that they'd actually turned the primary currents down to a point where they could cope with the task of replacing failed bulbs. And they hadn't told anybody, other than it was a sort of secret within the small group who actually did the job. And nobody knew this because nobody's ever tested. They were adjusting the job to something they could cope with.
So basically, what you're saying then, Tony, then it's really, it was done on a calendar based or an ad hoc based scenario. Initially, we merged into calendar based, doing the block changes. But of course, in today's day and age, with the tools that we have available to demonstrate performance, then we're into performance-based, aren't we? Targeted maintenance. Yeah. Hence, that's where the different name of differential maintenance came in. So we've gone from this era of calendar-based concept to performance-based concept.
Well, I'll just say one thing. The infamous 50% that ICAO has has in its documentation, a lamp is deemed to have failed if its only output's only down below 50%. Before that, there was absolutely no numbers at all. And I think it was probably my suggestion that, well, in about 1976, well, the poor maintenance people have got no guidance at all. We must put something into the Annex 14. We had no good data. So it was really just a wet finger in the air sort of thing. And so, well, 50%, but we need to do work on this to get a better number. But at least 50% would avoid the 10%. So I was finding in a lot of cases. So, they had got something they could measure their actual performance against. The intention was that we'd actually get a proper number in there, and that work was never done. And so that 50% was purely guesswork, if you like. It had no research or operational input, really. It was just to say, well, here's something. Let's start at least by getting rid of the real rubbish.
Mm-hmm.
The right number.
And one of the things I see as well is improvement in safety, or the attitude of safety. When I got into the trade in the late 60s and 70s, kind of the way you proved your manhood was when you got that shock that you were talking about earlier, that you got it, you're now an electrician. And you don't see that anymore. You see people understanding the hazards that are involved and taking the necessary steps to work safely.
And I think a lot of that is due to what Carl said, is for the various organizations over here, like the AAAE, for example. We've spent the last 20 years, trying to educate the maintenance people at airports as to what the systems are, how they function. And before that, it was, if the lamp is out, you go fix it, you go replace it. And I think because of all the training we've done, we've advanced a long way in the understanding by airport maintenance people, the critical nature of their job and a lot of the characteristics to look for so that we can prevent those major outputs that we see once in a while. So we've come a long way. Unfortunately, now the FAA has written these standards. And the first advisory circulars, I don't know, we started publishing them in the 70s or 80s. And they many times were not practical, and they threw in numbers because it needed a number. And and down through the years, we've seen the airport maintenance people increase in knowledge, but the requirements from the FAA side have not advanced, in my estimation, nearly enough.
Okay.
And nearly enough. And so we're now pushing the photometric testing. And it's a hard push with them. We have, within the last year, an FAA certifications inspector landed at a major airport, came in and said, we're going to test your lights. You have 5 steps of brightness on your lights. Let me see if they're working properly. So the maintenance person is just control his regulator. He goes through all 5 steps, all the lights are on. He said, okay, you're fine. That's it. No indication of getting out and doing the photometric testing. And so we're coming, and that's why we're revising our maintenance AC now. And hopefully we'll have enough input in that to put into it some of the parameters that are needed to give us long-term service in our systems. Hopefully we will, but I'll tell you, it's hard to crack the area we're dealing with, because it's a group lots of times that know it all. I can just give you another example. I think it was to Keith, something you were saying here. I can remember going into our nation's capital in one of the airports, and we were checking the current in the circuits, and instead of 6.6 amp, it was like 5.9 amps, to give you an example, down there on step 5, step 3. They said, you don't meet the requirements. They said, well, we keep it down so we'll have longer lamp life.
Yeah.
That was the statement made right out in the open there. And
Yeah.
nobody jumped up and down on that, except we who were doing it. Said, well, why do we have all these regulations? That's how you're operating. And so they're not enforced. And that's the big item that we're looking at now. You got to enforce those requirements, and we got to have checks that are done at the right time. And if you don't meet it, then your system is not operational. I could go on with, and I'm sure Carl can too, but we're making progress, but it is slow progress.
It's interesting that you say about that you just made, turning the current down, because there are, in the ICAO documentation, ICAO in Annex 14 refer to the percentage of brilliancy as the requirement. Yet when we look at the technical specification for CCRs, and we look at the design manual, which show a set of graphs, there is the top tolerance of the current value, and there's the bottom tolerance. So if we go to, for example, a runway related lights, which is 5 steps as the basic 5 steps, where ICAO call for 30%, they say 100%, 30%, etc. When we look at that's based upon the top tolerance of the current, where if we look at the bottom tolerance of the current, that's only 20% of light output for step 4, for example. So there is quite a tolerance there, and of course, when you get to CCR, according to the technical specification, they're based upon the bottom tolerances, not the top tolerance. So, so hence increasing the potential life expectancy of a tungsten halogen.
Yeah, good.
So-
Thank you. Thank you for that. Steve Martin has written in, Keith, and he's told us that the suggested new IEC 61820 minimum required installation resistance for new installations is going to be 1 gigaohm.
Yes, I'm aware of that. And I know some of the projects that I've been involved with, actually the specifications for a brand new circuit has been 2 gigohms.
Right.
So, but I know it's been a subject which has been ongoing, and I certainly 61820 is a process of being completely rewritten by the IEC. I know that Steve is involved as the British standards representative on the IEC Technical Committee 97. So
Right. I've just had a question. What is your opinion on the maintenance requirements that are specified from the manufacturers? Interesting question. I'd like to understand why that's been asked, but I mean, generally
generic,
speaking,
because it's
follow-
generic.
yeah,
you
follow,
know?
yeah, I'd say follow the maintenance. You should follow the maintenance requirements specified by the manufacturers. There are one or two instances where they don't, they're inconsistent with the standards, and we certainly bring those to the attention of the manufacturers when they happen. And I would recommend if anybody sees those, then they should do so likewise, because we're all only human. But yes, I mean, it's always a good start point is to read the manual and follow it. I think if everybody followed the maintenance requirements specified, the lighting would be a lot better out there for our pilots, because you know, we're talking about some very detailed things here, but you know, principally it's the you know, it's the lack of maintenance is probably the number one cause of poor performance. I'm afraid.
The atmospheric conditions are different, aren't they? When you go
Yeah.
to the Arctic or you go to the tropics, you
Yes,
know, the scenarios are different, aren't they?
Yeah. Right. Look, it's half past now. We've run over overtime. I'd like to thank everybody again for all of your questions today, participating in today's webinar. The next webinar will be held on the 27th of June, which will be on the topic of after sales service. I'd like to thank our panelists today, Keith, Tony, Carl, and Seward, for their excellent contributions. I really take my hat off to you, gentlemen, for your breadth and depth of knowledge and your commitment to this industry and making it safer. So thank you for that. I'd like to thank Damon and Felicity for helping us to prepare and present today's seminar. Without them, I certainly wouldn't be able to work the technology. And I hope to see you all again on the 27th of June at the same time, wherever you are, on after sales service. Thank you very much, and have a lovely week. Goodbye.